Thank you for joining us. This is Paul Wilson.
And Chris Emke.
You're listening to the Diesel Performance Podcast. L5P week continues.
It's crazy, again, to think where we're at now and how much information we've gathered, from other people within the diesel industry as a whole over the last couple of years.
Yeah, hey, I want to give a shout out to somebody who I think a lot of people would see as like a competitor of Duramax Tuner, although we really don't see each other like that. That's Corey Willis.
Yeah.
PPEI, Corey Willis, obviously he's big in the delete game. He's big in the tuning game. He's big in the Duramax world. He does sell a lot of similar products to Duramax Tuner. They also offer the line of Stealth Turbos. Stealth Turbos. So we've done a lot of work with them in the past and had a great relationship with them. Corey's been very vocal and very open with sharing his test data. Yeah. So shout out to him for that. Definitely helping out the industry in the positive manner. Also, Nick Pregnitz from Duramax Tuner was just featured in a video for Diesel Insights, driving the L5P, giving you an idea of what is it really like to be behind the wheels, and also some really honest details about where we're at in the industry and where we're at with those products available for you. And this whole L5P ramp up and race to be able to launch a product, it reminded me of another RPO we released, we'll say recently, last couple of years. Yeah. And that was back when we did the 2.8 liters. Yeah. Do you remember when those were first coming out? We had heard that they were out in New Zealand forever.
And I like where you're leading this conversation. Yeah. Support was released a few weeks ago. Okay, that's where we made it publicly known. Guys, you're calling in. I know you're calling PPEI. I know you're calling Duramax Tuner. It takes time. Speaking on, when we interviewed Chief Engineer of GM, Nicola Menarini.
You got it. Yep.
So
XLD Program Manager.
The 2.8 was overseas with no emissions for years, and then they had to adopt emissions and study that and get that tried and true before it came to the U.S. market.
Yep.
It's a platform that's now been in the U.S. for 3 years. It's pretty trouble-free. Like, they're a nice platform. But there was 4 or 5 years of testing prior. That's right. And that's just what was overseas. Like, how many other years through GM was there for testing?
Well, even also, it came here and it was released. It was immediately supported by EFI Live because they had already been supporting it overseas. Yep. So when the 2.8 liter Duramax got released here in the U.S., all the tuners had access to everything. Like, it was full open access.
Nick had files for years.
Right. Yeah. But the ability to actually test it in real world and the practice of just setting up a file on your computer are going to be two very different things. And I think what a lot of guys in this industry are looking for is when they make a large investment, for most people, the second largest financial investment they're ever going to make is their vehicle. Yep. They want to make sure that it's right. They want to make sure whatever mod, with tuning, turbo, tires, whatever they put on, they want to make sure it's finished. Right. It's been R&D. They don't want to be a guinea pig.
Oh, and I mean, I've had guys already like, hey, I want to tune. Well, I'm not going to use your truck as a test dummy, even if you volunteer it. I don't want it.
No, it
Let us do it in-house. We want it controlled. We want to know the quirks, gains, downfalls. We want to experience it firsthand. We want to have the seal of approval when we go to market with something. Are we ever going to be the first? No, we're definitely not.
Yeah.
Will I feel that what we bring to the table is better than anything else on the market? Well, yeah, I truly do.
All right.
But that takes time.
Yeah, absolutely. And speaking of when we talked with Nicola Menarini of the GM program, the Chief Engineer and Program Manager of Duramax, we thought that was a really good episode to kind of bring back right now, to hear an OEM side of developing a new platform, launching a new platform. And he also, even back then, gave a couple of inside information about what were going to be some of the things we saw, which now you can go back and actually go buy those products. Most of them. I don't know if you can get an Equinox diesel yet, but I've seen. I mean,
they're out there.
I've seen more marketing about it. We'll say that. So, guys, go ahead and give it a listen. This is GM Chief Engineer and Program Manager of Duramax, Nicola Menarini.
Welcome to the Diesel Performance Podcast, a production of Calibrated Power Solutions, home of DuramaxTuner.com, a company and brand dedicated to emissions-equipped diesel performance for Duramax, Cummins, John Deere, TDI, and many more, makers of Stealth Series turbos and DT Series built Allison transmissions. In this episode, we welcome General Motors Chief Engineer and Program Manager of Duramax, Nicola Menarini, who has nearly 3 decades of worldwide diesel industry experience.
I started as a young engineer working on diesel engines, and I'm still here. This is an exciting world.
General Motors' investment in diesel continues to grow with 3 engines now in production: the next generation Duramax, the 6.6-liter L5P, the 2.8-liter, and the 1.6-liter known as the Whisper Diesel. So let's get started.
So today we are being joined by Nicola Menarini. Do I have that pronounced right, sir?
Perfect.
Excellent. Thank you so much for joining us today.
Good morning. Thank you.
No problem. No problem. You know, Nicola, we're really excited to talk to you as we understand you are the chief engineer of the new generation Duramax, a lot of experience in the 2.8-liter Colorado and Canyon platform, which we love here. And as well as I hear there's some new news out about the Cruise Diesel. So
Yes.
awesome.
Yes.
Well, I know we're going to dive into all of that, but first, can you give us a little bit of your background so our listeners know where you're coming from?
Thank you. Thanks for this opportunity. Good morning, Nicola Menarini. I'm Italian, perhaps easy to understand. I've joined General Motors in 2008, and I am a 29-year-old guy in the diesel field. I started as a young engineer working on diesel engines, and I'm still here. This is an exciting world. And as I said, I started long ago in Italy working on diesel engines. I had the pleasure to work with many of the automakers. From the late 80s, I worked with Chrysler, Alfa Romeo, Rover in England, and many others, including GM. Not only in automotive. I also had the opportunity to work for a short time back in the late 90s with the Detroit Diesel. I worked for Roger Penske, and still, getting a lot out of my experience with Detroit Diesel in the heavy-duty world. Later, I joined General Motors, and I've been in charge for several years, as you anticipated, of the 2.8-liter, which is currently used on the Colorado Canyon as of 16 Colorado Canyon. We recently launched it here in the U.S., and that's has been really a home run for us. We introduced that engine earlier in countries outside of the United States, and introduced it into the U.S. when we thought it was mature to enter this market. As we were saying also, we have some kind of common strategy and approach to the diesel world into the United States. As you have anticipated, of course, we're talking about the Duramax today, where the Colorado Canyon, they are already available as of a little more than a year ago, if I recall correctly, into the U.S. market. And the good news, what we really are happy about, is the result we just achieved on the new Cruise, which has hit 52 miles per gallon highway, and it is the highest non-hybrid, non-EV mileage ever in the United States. So we're very, very proud of this new diesel engine that will be available to Chevrolet customers here in the U.S. very, very soon. Also with the manual transmission. That some customers was really
nice.
Yeah.
That's huge. That's huge. Are you kidding? That's one of the big things. I mean, a manual transmission in a little car. I love it.
Yeah. You remember we had a Cruise with the diesel a few years ago available in the U.S., and some customers were really requesting, why you guys are not offering a manual transmission? So, okay, the customer input went into planning, and now it's a reality. And of course, it's available also with automatic transmission, but now the customer can choose between the two alternatives.
Yeah, we like
that.
A little car,
we like that. For a little car, a small car like the Cruise is small and comfortable. The manual transmission may be something that some of the customers would like. It's fun to drive, and maybe with the manual transmission could be even maybe a little more fun to drive. It's a very high torque engine, 240 foot-pound.
Wow.
Despite the small displacement, and very, very quiet. In Europe it's already used, and it's called the Whisper Diesel.
Really? Is this a version of the same 2.8 or 2.0 liter that you guys were using in, was it 14 or 15?
No, it's a totally new engine developed by GM, really focusing on lightweight, high performance, NVH, and definitely fuel economy. It's on sale in Europe as a few years ago, and even in this case, we wanted to gain experience in other markets before launching it into US. And now here we are with the Cruise.
Can you tell us, Nicola, what is when you say launch in other markets, like, the same way with the 2.8 liter? So GM took the 2.8 liter globally before it came to the U.S.
Yes.
And it sounds like you did the same strategy with the Cruise.
Yes.
What are the unique challenges of the U.S. market?
Well, for sure, the U.S. market is very challenging in terms of emission compliance, and clearly the highest quality standards have to be met. So, especially in recent times, we put a particular attention to develop systems, and we're entering also in the control area, not just the typical hardware of the engine, which can be absolutely robust and safe and compliant to the very restrictive U.S. emission requirements. We entered, for example, the 1.6, for example, it was already born as a Euro 6, so in a pretty advanced emission capability level, and then was developed to enter into the U.S. Just a couple of years.
The Euro 6 is a very stringent emissions level.
Very stringent. Okay. So it was launched in Europe in 2013, and end of 2013, and gaining the experience throughout the Opel brand, and it's not only in Europe, because we also sell it in other countries, in Korea, for example, very well accepted.
Yeah.
And so this is it's not so different from what we did on the 2.8. Actually, the 2.8 we launched in early 2012 in South America and Asia, including Australia, very very demanding markets. In other, in this case, it's Euro 4 and Euro 5 configuration, and then we decided to bring it into US on the Colorado and Canyon.
Very good.
With the void that Volkswagen is leaving right now, I definitely see the appeal for like GM moving into these smaller vehicles and something that's more consumer friendly. You had mentioned reliability, fuel mileage, and performance. How far do you guys push yourself? How long does testing or developing take on a small platform like that? Is it more testing because it's smaller components compared to, like, say, the new generation Duramax, the L5P, or are they about the same?
I would say that the durability, the validation, the development testing are tuned to the engine and to the vehicle. So, for example, our tests are not identical. If we have to test a little MBE, the so-called MBE, mid-size diesel engine, or the Duramax, they are different based on the weight of the car, based on the performance of the vehicle. So there's some tuning that are part of our standards into the development. Conceptually, in terms of criteria, they're exactly the same, but slight adjustments, slight difference in the number of durability cycles, extension of the time of the durability. It's tuned to the kind of vehicle that will have to use this engine.
Yeah, that makes sense. Can I shift your focus a little bit, Nicola, to the power curve of the engine, right? So when you guys are designing what spectrum the engine's operating in, how it's going to perform in the vehicle, how are the 2.8 liter and the 6.6 the same? How are they different? What special considerations do you have for a heavy duty platform versus a 2.8?
Well, of course, the heavy-duty platform has different demand. We consider that, to be honest, the heavy-duty platform was already in the U.S. since a long time ago, many years ago.
Right.
The 2.8 came after, so we thought the 2.8 could have been, let me say, the young brother.
Okay.
So clearly, for example, features like trailer towing capability, exhaust braking. We push ourselves to the maximum that could benefit the customers, the Chevrolet and GMC customers that do heavy towing on the heavy duty. On the mid-size, we're performing very well, I would say, but we're not pushing ourselves to the same extent for the simple reason that we have to dimension many components, for example, that we can do it on a 6.6. We cannot do it on a 2.8. So it's, I would say, a transition and downsizing of the performance, the transient, trailer towing and exhaust braking performance is transitioned, if the example works, proportionally to the engine displacement.
Okay. Now, you have quite a bit of a history in building calibrations for OEM. Is that correct?
Yeah, I maybe 25 years ago I was doing calibration myself, so I've been always quite close in my role to how the calibration is developed, and that's a key feature, especially in current times.
And you're currently, as you orchestrate these platforms and you bring the mechanical side into the calibration side, what kind of feedback are you getting from customers? What are the demands on the 2.8 as far as like transient response, or on the heavy duty platform? Like, what are customers pulling from you guys? What's the struggle?
The transient performance is something we really do our very best in order to give the best feeling, I would say, drivability feeling for our customers of Chevrolet and GMC. Not always easy, I would say, very honestly, on a diesel engine, on a turbocharger, because not that we have the turbo lag, but in order to give the best acceleration, we should have a boost available. And if you push the pedal wide open from idle at particularly low level, it is necessary, and this is physics, some time for the turbo to start spinning fast and boosting and pushing air into the manifold. So, but there is a lot we can do in terms of calibration. Also, we have to control the air-fuel ratio during the transient performance, because if we do not tune the air-fuel ratio in a very accurate way, we risk puff or smoke. We won't. The puff of smoke is clearly not visible anymore on diesels because we have trap filters, but the physics is the same. And we want also our customers to have a long enough regen interval, which at the end of the day is influencing a little bit the fuel consumption.
Yeah.
So it's a fine tuning, and also, for example, gear ratios, drive ratios play a good role.
I like what you're going with there, and you guys have stayed with the Allison 6-speed for 17 years now, or the Allison transmission, now the 6-speed.
So far.
So the gear ratios seem to be working for you. The transient response in the L5P is much improved, I'll say, over the previous generations. The truck feels snappier. It feels like it has more torque. From a driver perspective, I would say it's much improved, more so than the power numbers would indicate even.
Yeah, the power is always a number that is nice to see, but at the end of the day, it's up there. It's maximum RPM.
Right, exactly.
So what the customers feel, this is even more valid for any diesel engine, is the torque, and not even the peak torque, but the torque and the end. And this is what we have been working on in all our applications. Because sometimes you can say, you have an automatic transmission, so you don't need the torque and low end. That's not true. And this is why you can find also on the Duramax a brand new turbocharger, which is offering a better transient response. We have positioned it closer to the exhaust line in order to minimize, let's say, the impact of the gas column and the potentially transient, delay in the gas flow to the turbo. So this is one of the reasons. And plus we are, as always, applying the enhancement that the technology is bringing forward. And the turbo is, of course, one of the tools that we have to give a better drivability to our customers.
Yeah. I love that. That's a good segue. That Borg Warner turbocharger and that response, right? I mean,
well, that's it. We noticed that there was a big change in turbocharging when the L5P came out. That was probably one of the first things that we spotted, was getting away from the previous stuff and now having a Borg-Warner in there. Also, we noticed that the emissions equipment placement changed around a little bit. And I'm wondering, does the emissions equipment, is that a factor you have to work against or fight against to get transient response? And I think, can I just clear it up for our newer listeners? Transient response, that's throttle response, is really what we're talking about here.
Yeah. Well, emission is first, and the transient response is to be tuned accordingly. I would not say that the after treatment which we have is too much influencing in a negative way the transient performance. You can very clearly see that on L5P the architecture of our treatment is totally different. What you will observe immediately is the enormous catalyst that we have positioned in the middle of the V.
Right.
That's really key for emission. That's only a DOC. So it's being a catalyst. It's not a trap. It's not a filter. It's not an SCR. It takes care of unburned gases. And more than that, being so close to the turbine, it helps to keep the temperature of the exhaust high, which is fundamental for what is happening downstream of the DOC on the line. In order to have the best conversion efficiency of both the PM and also the NOx, which is the enemy of the diesel in this period, we have to keep the exhaust temperature high. So having a catalyst just downstream the turbocharger, very close, actually connected to the turbocharger. There's no distance,
right?
Just the clamping in between.
Yeah,
it helps a lot to keep the temperature high.
And when you say keep the temperature high, is there a time, like what I've noticed in driving and observing exhaust gas temperatures on the LML and the newer emissions equipped trucks? I haven't got a chance to look at the L5P yet. Is that the truck is trying to get the after treatment to 550 to 600 degrees as quickly as it can, and it seems most frustrated with me when it's cold.
Absolutely true.
It's really trying
you're
to get...
absolutely true.
Mm-hmm.
There are specific strategies in the fuel injection system in order in the first seconds or minutes of the cold operation to warm up the exhaust and then warm up the DOC as quickly as possible. And this is in fact very important. It's our development goal is to have the exhaust warm, hot, in the temperature range you just mentioned as quickly as possible, and keep it during engine operation.
You mentioned the fuel injection system. Speaking of changes that we've noticed directly, we noticed that there was a big change in the injectors. The current Denso injection system, how has that helped the emissions equipment and the performance of the L5P?
Well, the Denso, first of all, I mean, we're talking about 2,000 bar, and we're talking about a system which is developed and is currently, you can find it on not just on the Duramax. This is a system that we developed in collaboration with Denso, and not a coincidence that you can find something very similar in the 1.6 we just discussed before, and in the 2.8.
Okay.
It's a solenoid fuel injector. Fuel injection. Fuel injectors are solenoid driven.
Right.
We did not really find much advantage, especially with this latest generation solenoid versus the piezo. So this is why our decision was to go straight to the solenoid. And we have, of course, the really important activity that was done on all the three engines that you can find on our vehicles, on the Cruise, Colorado, Equinox, even Equinox we didn't mention, and Silverado. And I just forgot that there may be a van that you guys will see very soon. They have to be tuned together with our controller and our strategy. So we built the strategy, the control, the calibration, really tuned to the hardware of injection system. And this is a winning point.
Okay. Okay, I like that.
I think we just let slip there, and I don't know how many of you guys are following kind of the overseas diesel industry, but we've heard rumors about the Trailblazer, the Equinox, and now the van. Obviously, GM is from a position that diesel is taking off. What kind of changes are you seeing from the calibration side? So as you guys are tuning these from the smaller engines compared to the bigger engines, what kind of big changes do you have to make?
I would say that calibration is very much vehicle dependent. If you, there are a lot of features that are in the engine, but they are vehicle dependent. And if we go also a little bit outside the US, they are very much emission rule dependent. So, for example, if we take the Colorado for US, we test it on a Euro 6, for example. We have to do some work to optimize it. So it's engine related, it's vehicle related, and integration related. I mean, devices like, just a simple example, the air cleaner box. We have a mass airflow sensor into the air induction. That's basics to have a perfect functionality of our system. So, for example, just to give you an example, even a small change to the air filter box, maybe just to the cartridge, can influence the way the sensor is reading the airflow and then the way the system is reacting to airflow changes and adjusting fueling and exhaust gas recirculation. So it's very much also related to the vehicle itself and the interfaces between the vehicle and the engine.
I'm glad you brought up the mass airflow sensor on these trucks, because we've noticed in the past that even it's very common for aftermarket installs of air filtration upgrades or changes, and it's interesting to see how quickly you can throw that system off by misreporting the mass airflow.
Absolutely.
I want to.
We just to give you an example, we controlled the system tolerance very, very carefully. We need to ensure that the combination of the sensor itself and the induction system, which is a plastic box with a rubber hose, they have to be within very, very strict dimensional tolerances in order to guarantee that the reading of the sensor is accurate with a very small deviation sensor to sensor. We call it the min-max adjustment.
Okay, that's good to know. Going back to the calibration side, Nicola, there's been a tendency in the past, 10 years to go from 23,000 psi to 26,000 psi, and now to 2,000 bar. Sorry to switch units on you, 29,000 psi, and to continue to increase the number of injection pulses per stroke. All right, so to control NOx emissions or NVH. Do you see this trend continuing, or are we at a good point now, a good stopping point? Is 2,000 bar it?
We will probably see in the next years higher numbers.
Okay.
Of course, we are no need to deny. We are working to injection pressures that are higher than 2,000. And I'm not able to tell you whether it will be 2,200 or 2,500 or so. It very much depends on what we can offer in a reliable way to our Chevrolet and GMC customers in the future. We definitely will offer products with higher than 2,000 bar in the near future. So far, what we've been able to achieve with the 2,000 bar, which is 29,000 PSI, if I'm not wrong.
You're right.
It's okay for the current need. But as emission requirements will continue to be more challenging for us, the availability of higher pressures give to our calibration and after-treatment development folks more freedom to work around and be able to achieve what we need to achieve
in shaping peak cylinder pressure
way.
Yeah.
Exactly.
Yep.
Okay. Nicola, you had mentioned pushing the envelope and still testing reliability. Now, we know that there are no SAE standard reliability testing really out there, right? So how do you guys really feel about reliability? How do you guys kind of respond when guys ask you about the reliability of the engine?
We have we have our standards that are say based on what we believe the durability. Durability is one thing. Reliability is slightly different. If we talk about reliability, clearly we adopt all the quality standards that GM has developed throughout the years in order to ensure, which go from how we treat how we design the parts, how we treat the parts, and during development, our suppliers are treating the parts, the quality that our suppliers can guarantee to GM, and at the end of the day, what we can do in manufacturing, both in the engine plant and vehicle plants. In terms of reliability and what we can offer to our customers, what we do, of course, and this is not just GM, but is industry standard, before offering the vehicle to our customers, there is intensive fleet testing that we do, both dedicated, of course, these are fleet testing with vehicles that are off production or basically pre-production vehicles that are completely representative of what we will offer. We will do specific testing including different climatic conditions, but also what we call capture fleets. So there are pre-production vehicles used by GM experienced employees that accumulate mileage and give any warning that we could get in order to correct anything that is happening eventually and avoid any issue going into our customers' hands.
That sounds like the best job at GM.
Yeah, it is, and it's very, very important for the development teams and for quality because also, first of all, the drivers of these vehicles are particularly empowered, and they feel everybody, even if they're not working on the same program or working in maybe finance or purchasing, they really feel part of the development. This is a feedback that is really exceptionally helpful to ensure our quality standards are met.
Yeah, I like that. And you went strong into the reliability side of things. Can we push you down the durability road a little bit? What can you tell us about durability testing and how that affects the heavy duty platform?
Durability testing on our engine is, as we said before, is done based on some standards. We have extensive testing and not just full power testing. I can give you as an example. We have testing that are, testing at wide open throttle, but we not only test the wide open throttle condition. We have, for example, tests that are keeping the engine for thousands of hours, I would say, at low speed, because the low speed is cold temperature, and maybe we have to ensure the engine can operate also at low speed for a long time.
Okay.
Then we have tests that are, for example, shocking the engine with hot and cold operations, and this is also very, very important to ensure that no issues can happen for very long miles, even for people that is, say, starting the engine at 0F and warming up from there.
Very good, very good. Thank
Absolutely.
you for that.
Yeah, because we get a ton of guys asking about low speed or idle with these, and obviously in the past we've never really considered that to be a stressful operation for a Duramax. Now that we have emissions equipment, it's kind of a whole new story where we're coaching guys on how to operate their trucks.
City driving and low speeds.
Yeah, they want to know what they can do to maximize their driving experience. They know that you guys test for everything, but they want to do their part. And if there's any advice you can offer them, I'm sure they would be open to it.
I would say that in general, this is something that, as a few years ago, one of the best achievements I think that the diesel community, and it's GM and non-GM, has achieved is that we basically stopped talking about the smoke. There's no more smoke. And this is due to the introduction of the particulate trap. Particulate trap is a sophisticated system that is accumulating the the PM, the carbon deposit, let's say, that the engine is naturally emitting, and regenerates, can automatically, say, burn these deposits by artificially increasing the exhaust temperature. This is happening in the best way when the temperature, as we said before, the exhaust temperature is high. When the engine is at idle and remain at idle for a long time, it's extremely difficult to keep the temperature high enough. So the message that we could give to our customers, is especially to the customers that are used to do short driving patterns and very low speed, long idling, is that it may be a little annoying, but for the if you see the message, keep driving, please keep driving. Your Chevrolet or GMC is not lying to you. If you are to the extent to get this message, please follow the message, spend a few minutes driving, and you'll be okay.
I swear I'm going to isolate that and just play it for every customer who calls in to ask about it. That was perfect. Absolutely. When it says keep driving, just keep driving. Yeah. It's so simple.
The vehicle is transparent. It's telling you, hopefully, the truth.
Yeah. Well, you got a guy like Paul that lives 2 miles away, and he doesn't let his truck warm up in the morning, and he's driving, as fast as he can to work.
No, hold on. I idle longer than I drive. Everybody knows that. Yeah. Yes. 20 minutes of idle, 4 minutes of driving. That should clear it up.
You should not be buying this truck.
No.
No, clearly, for in extreme and intensive city traffic, one should ask to himself whether, and this is very general, whether the diesel is the right choice or not. Right. And we have to be honest and transparent.
Right. Well, speaking of, who are some of the perfect people for a 2.8 liter? Like when you guys were developing and testing this over the last several years and thinking about bringing it into the U.S. market, I'd imagine you had an ideal customer in mind. Who's this truck built for?
Wow, this is a difficult question for a poor engine guy. I would apply. The vehicle is a similar Colorado. You guys may know there's a slightly different platform, but it's still a Colorado and it's still a great Chevy badged vehicle. Is built in Thailand. I would not say that for US we target the customer to be like in Thailand, when you can find in the rear of the Colorado 10 people going to work, but completely exposed. But in any case, I think that in very simple words, my comment would be, it's somebody that desire the flexibility, the friendliness of a pickup truck without going into the Silverado dimension. Yeah. So there may be truckers who really don't need the Silverado, and maybe we can probably say cannot afford also the Silverado, and then we said, okay, let's offer the midsize, and I think the reaction of the public has been telling us that we were right.
I would agree with you. There's been a strong reaction to that truck. I mean, it's very popular.
We have some diesel penetration, which is expected. Of course, most of the volumes of Colorado and Canyon are on the gasoline engines. You know, we have the 2.5 and the V6.
Right.
But the diesel is entering with quite significant numbers, and maybe a little more in future. Customers are pretty happy about that. We have good feedbacks. And we're, of course, working to improve what we can for the next years.
I would say, personally, working with a lot of 2.8 customers, I've seen a lot of first-time diesel buyers own them.
Yeah, absolutely.
I've seen a lot of that, and I've also seen a lot of guys that own them that also have a full-size Duramax.
Yeah. Yeah, they seem to be great daily drivers, or somebody who only tows something once in a great while and it's a real light load. Those guys seem to love it because the fuel mileage and the cost of ownership's lower than the gas stuff for some guys, depending on your application.
Yeah.
Okay. Yeah. Now with the cruise in mind,
we didn't forget, of course, just to jump in, the trailer towing guys on the Colorado. The trailer towing is particularly, I would say, for a medium-sized truck. If I recall correctly, maybe the number is not perfectly in my mind. We have 13,000 gross combined, and this is covering the need of many customers. I've been also with the development team doing up and down Eisenhower Pass many times in the past to ensure that we can offer also from a mid-size truck the best possible performance for our customers.
Absolutely. I mean, having towed with the Colorado, I was not expecting very much. You know, I've had S10s in the past in small trucks, and I put my Nova on a car trailer behind the Colorado just to see what it was about, and I was impressed with it. Not only the powertrain, but the platform, the chassis itself felt very stable. I felt in good control of the vehicle.
Yeah.
Even the braking
Good
with
to know.
it. Yeah. Yeah, and listeners, if you guys want to check out that video, you can hit the Duramax Tuner YouTube channel. Just look for Colorado. It'll come up.
towing test or something
like that. Yeah, it'll come up. There's a few of them. Okay, if we could jump back into the Cruise real quick. You had said that this was designed for a little bit more of a sportiness. Are we seeing a power increase as the new Cruises are coming back to the market with a new engine?
I'm not sure I can share all.
Okay.
So far, I think that if you drive this vehicle, unless you did it already, you'll find the power adequate. There may be evolutions coming. Remember, it's just a 1.6, poor guy.
Yeah. I mean, the earlier Cruises that we tuned, Paul, I want to say 240 foot-pounds that's very fun to drive in a car that size.
Dude, the Cruise was one of my favorites that we've had here. For being somebody else's vehicle and, like, not a sled pull drag race truck. Because we get a lot of daily driver vehicles in here from customers or other vendors that want us to play with them. And the Cruise was just so damn comfortable. It just really was.
Yeah, it was a nice cruiser.
Yeah.
It is really a vehicle that is fun to drive, comfortable, very nice vehicle, both in version, also hatchback, who is available, and we expect some success out of there, up to that vehicle.
Well, it makes a lot of sense why we don't see these vehicles until you do some testing in other test markets because of our stringent and strict laws. So it was really cool to hear your side of it, knowing why we don't see it until later on.
Yeah.
I have one more thing I want to jump into on the L5P, and maybe you can talk about it, maybe not. Back to the after treatment system. Question one would be the ninth injector was previously used on the LML trucks. Is that still a strategy you guys are using? Is the hydrocarbon injector specifically for the exhaust?
Yes, for both the trucks, the 2.8 and the 6.6, we have. In this case, the ninth, and the other is the fifth, but we have the injector in order to help, I would say, the DPF regeneration. Okay. Two main reasons. First of all, you see that the architecture of the exhaust foresees DOC, then the SCR with the urea, the DEF injection, and the particulate trap is at the very end. So potentially, it could get colder because it's more far from the source of the heat from the engine. Okay. So with the injection of additional fuel, just upstream the DPF, the particulate filter, which has a built-in catalyst as well, we can ensure that the regeneration temperature in the area of 600 degrees is achieved easily. In addition, we can operate the regeneration counting more on this post-injection outside the engine rather than pushing to the extreme the post-injection inside the engine and injecting fuel in proximity to the bottom dead center, which is, of course, something that possibly we have to reduce.
Right. We ring washout and crankcase fuel. That kind of thing. Okay.
And on a large engine, this is even more important. But I would say the most important is that the most important reason why we keep it is that due to the architecture, the particular trap is at the very end. We need to keep it hot, and we need additional fuel to regenerate it and to make the regeneration shorter also.
Yeah, we like to hear that.
All right.
Regeneration cycles are one of the biggest questions we get asked by customers who call in. Does tinkering with the truck make the regeneration cycles, more often, right? So that's their big question they're asking us. My concern or my question for GM would be, it seems like every platform we've seen on the Duramax as it moves forward on more strict emissions laws is one, a bigger particulate trap. Seems like every generation gets a bigger particulate trap, and it seems like our distance between regen cycles and our propensity for passive regen goes up every generation. Would that be a reasonable thing to say about the L5P as well?
I would say yes. Of course, we try to keep the regeneration interval as long as possible. But more than that, because at the end of the day, it is fuel consumption. It's a balance, of course, between ensuring that the trap doesn't get overloaded, which is absolutely our must number one, and of course the way that we can trade on the emission of soot and the need of regenerating the trap not so frequently. What is, however, our goal is to possibly avoid any impact to the customer. So the customer should not care about the regeneration. It's something that is happening. It's something that is taking care of the particulate trap. The only, I would say, as we discussed it before, the only real interaction of the customer with the regeneration could be when, in case of the keep driving message come up, and this is the only real interaction that we are forced to ask to our customers to have with the regeneration criteria.
Yeah, we like that. I mean, we like to have the seamless system. Of course, some customers are very curious people, and they want to know what's going on in the truck and how often it's regenerating and how it's impacting their fuel, and we have to accommodate
all the customers, I would say.
It very much depends on the driving style. I would say the more the customer is driving, say, in a highway mode and constant speed and keeping temperature up because of, running the engine with use of quite high level of power, then the regeneration may be less frequent. If instead we are doing, for example, frequent wide open throttle acceleration and then longer period idle, then of course the regeneration can happen more frequently.
Yeah, so beat on your truck. Right. You knew I was going to say it. Yes. Beat on your truck, drive aggressively.
What can you tell us about passive regen on this system? Is that, let's say a guy has a trailer behind his vehicle and he's operating at high load on the highway. Can he expect to...
There is a balance. We do have some passive regeneration in the system, of course. It happens when the temperature is high enough. We can enable some passive regeneration without the need of post-injection. However, we have to say that when running with high temperature and towing, for example, the engine is also using power, a lot of power. Then also, of course, the emission of the smoke emission is also slightly higher.
Sure.
And in this case, this is not really bringing the interval to, let's say, 1,000 miles.
Okay, so it's a wash.
Exactly, it's a wash. The regeneration is happening naturally, but in the meantime, we're also accumulating a little more soot because of the utilization of the power. So the two, it's a wash.
Yeah,
gotcha.
Good insight.
Yeah, well, I think the odd thing here is that for all of diesel's existence, we've been told EGTs are bad. So get your exhaust gas temperatures down, bring cold air in, get hot air out, and that'll do it. And that's what every customer who calls in to talk to us wants to talk about is how can I get my EGTs down?
Yeah.
I've noticed OEMs in no year of any Duramax ever have they put an EGT probe on the exhaust manifold, which is where we do it in the aftermarket world. How do you guys measure stress on the motor? What factors into that? If it's not EGT?
First of all, I think this EGT is a big portion of that, and unfortunately there are different needs during the engine development. The after treatment would like to remain hot, but not too hot. Okay, because 600 degrees are good, 800 are not. So this is the difficulty that we have. The exhaust temperature we have, for example, in the turbocharger, we are in the area of exhaust gases entering the turbo in the area of the 800 degrees, okay, on a diesel engine. You can have a constant to, if I'm not wrong, to 780 degrees. This is what you can handle continuously. Peaks are accepted above 800 degrees, and this is how we develop too. So we do during the development, which is both on dyno and on vehicles, we do control that in no one case we exceed this specified limit in order to guarantee the due reliability. So I would say, to give you a number, we can accept some exhaust temperature, as you said, in the exhaust manifold, so upstream the turbine, in the area of 820, 810 degrees. Occasionally, it cannot be a continuous operation. And this is how we develop the calibration, how we develop the hardware, and this is, I would say, quite standard throughout all our diesels. There's not big difference between the MDE, so the 1.6, the 2.8, and the 6.6, the big Duramax. The criteria are more or less the same. One thing is the engine on the dyno, where we have to control it in a relatively easy way. One thing is an engine going wide open up Eisenhower Pass,
Right.
where you may have a little bit of help from the ambient temperature,
Of course.
because it's not in the not 100 F, but maybe a little lower. But on the end of the day, also the underhood temperature can become critical. So we have to control the 800 degrees also in that condition. And also the ambient air is not always entering the compressor exactly at the ambient air. We have some effect where when the air is going through the air cleaner, the filter box, it gets heated. And then it's a chain, We're going to the compressor, already hotter than the ambient, then it's compressed, so the temperature can go up a lot. Then enter into the engine and we have the combustion. At the end of the day, this is matter of very long and extensive testing, especially for the trucks, in areas like, as I said, the Eisenhower Pass, and specific tuning in order not to exceed the durability, reliability parameters.
Yeah, that's beautiful, man. I mean, you just made a really good case for a hood scoop. And I just want to jump in really quick here and just, so Nicola's talking in 800 degrees centigrade. So for our listeners keeping track, that's 1450, 1470 on the Fahrenheit side. So just...
Yeah, actually 1436 should not be exceeded in continuous operation. Never.
I appreciate you sharing that information with us and our listeners. That is good to hear from the horse's mouth.
Absolutely.
I don't think, to be honest, it's just GM. It's sort of industry standards because there is some kind of... we do not go to... the gasoline turbocharged engines go much higher, as you know. Mm-hmm. But in the diesels, this is the range that we normally deal with.
Is there some sort of concern about parts not being able to sustain efficiency at that? Is it that the turbo won't be able to compress air efficiently over that temperature? Where do you think the drop-off is or the risk is of operating above that?
What's the first failure point?
No. Functionally, it's okay. I mean, it works. And the exhaust side, we have a very high resistance cast iron and the turbine, even higher resistance the wheel. Compressor side, we have aluminum housing, and we have a cooled turbocharger, by the way, in order to avoid any shock in case of soak. This is extremely important, the turbocharger. But for this kind of temperatures, we are not seeing the performance degradation. We're simply, I would say, these are thresholds that are dictated by quality reliability criteria for our customers.
Very good to know.
Copy.
So what you thought previously about a diesel. It's a lot different nowadays.
Yeah, well, how many guys call in, Danny, and say, my truck's operating at 1,150 degrees and I'm really worried about the reliability of it? And we generally scoff that off, kind of explain to them how
if
EGTs
it didn't have
work.
an after treatment on it, it'd be one thing, right? But if it has an after treatment on it, you have to expect it to try and get to a certain temperature. And then if it exceeds, then be worried, right? But 1,000 degrees or 1,100 Fahrenheit is nothing to worry about.
And first of all, when talking about temperatures, you may have seen that in our after treatment system and also in the manifold, we have many exhaust temperature sensors. The temperature, of course, is going from the hottest point, forgetting the combustion chamber, of course. We have this 800 degrees or 1436 we have been talking about so far, going down while the gas goes through the DOC, the SCR, the PM, and leaving the exhaust to the open air at the end. So there's, of course, the temperature is gradually reducing while going to the outside.
Yeah.
So we have to, and I mean, sometimes I friendly call our exhaust system in the end, which is very similar if you see the Colorado Canyon with the 2.8 or the Silverado Sierra with the 6.6, we have 5 exhaust temperature sensors in the line, plus 2 on the engine. These are needed not just because we need to control the temperature, but because through these temperature measurements, supported by analytical mathematical models, we guarantee emission and diagnostic compliance. So most of them are used for diagnostic reasons, in order to be compliant with the EPA and CARB rules, which means if some of the catalysts is not efficient, we see something unexpected in how the temperatures develop, and then we send a warning. So most of these are required for diagnostic reasons.
Interesting. That's curious.
Yeah, that's a lot to chew on there as we're starting to think about it, right? Because I know that I'm thinking of 3 EGT probes in the LML, right? So
four I'm thinking.
4?
4 banks that you can pull up on the edge at least.
Right.
Yeah. I mean, it's just neat to know that the system is looking for certain temperature drops during certain operations, and if it's not seeing those, that it can troubleshoot itself.
Exactly. Yeah. That's exactly how the diagnostic works. And it's needed in order to guarantee our compliance and to the laws, because to be honest with you, the calibration of the engine is becoming a little portion. The most difficult portion and challenging, and where we have, I would say, great advantage is the diagnostics. Diagnostics is in this latest emission requirements that we have in the U.S. are very, very stringent. Not only we have to meet emission levels, we have to meet the diagnostic level, and we have to be able to demonstrate that we're able to monitor and diagnose and basically get any malfunction of any of the systems. This is why we have what I call the chemical reactor behind our engine. We have exhaust temperature sensors, we have NOx sensors, upstream and downstream the SCR. We have a soot sensor and we have a delta pressure sensor on the DPF, and they all work together.
I hope.
Yeah.
As the trucks get newer, the emissions equipment gets better, and the more data trouble codes we have, the easier it is to diagnose a problem. And God forbid if there is one.
Yeah. Yeah, well, I think that, as obviously Nick, Danny, and I are from the aftermarket world with diesels, we kind of wonder sometimes about GM. Do you guys, is aftermarket diesel performance on GM's radar? Does anybody in the development process know what sled pulling is or ever watch diesel drag racing? Or you guys taking note of what we're working on?
We were giving an eye. I personally have to tell you, I'm not completely aware of what you're asking. I was making fun. I would say that with this latest Duramax generation, we make the life a little more difficult because we are much higher in performance than we were before. So for whoever wants to enhance the performance of current current Duramax, it will be more difficult.
Yeah, we've noticed that your driver's wish, the truck is much more responsive. It acts a lot more like a tuned, a tuned version of the previous generation.
It's tuned by homeroom.
I love that. Well, it does make me curious because in the aftermarket world, obviously here we've worked on twin turbo emissions equipped projects. Danny, you drove clean sweep all year last year, built trans and modified turbo and things like that. And so we always kind of wonder, are we gonna have to start competing with the OEM, or are we always going to just be able to improve on what you guys have given us?
Yeah, ideally, I think we work together as the LML, for instance, right? The clean sweep, we take a 360 horsepower truck and we nearly double its output. The L5P, what the guys in the aftermarket are looking at already. This thing's nasty right out of the gate. How much more power can I add to this truck?
The overhead. What's the overhead?
What's the overhead? Yeah, what's left, right? What's the durability test tell us? It's part of the buyer's consideration. Is what it boils down to, and it's something they're interested in.
If we need to climb the Mount Everest with this version of the Duramax, we are at base camp 3. So,
so there's some overhead.
Well, a little bit. That's the.
I like to hear that.
No, clearly, I'm not sure, to be honest. The race to maximum power will continue in future. Personally, I'm not sure. Everybody, we and all the competition, always going up in power. Is this what, at the end of the day, in the future, our customers want? I'm not really sure.
These customers
so we have to be very, very careful to monitor this. What the customer will desire, will have in future. We may have something additional to offer and more power, but we're trying to develop other ideas inside GM, how to offer additional performance.
Well, that's just awesome. Nicola, we really appreciate your time so much today. We know how busy you are and how many important things you're working on. Any last notes that you'd like to give our listeners about the Cruise 2.8-liter or new L5P project?
I got one.
We are now on the market with these 3 vehicles. There is a lot of commonality work that we have done. We work, as you may know, the diesel home room is in Torino, Italy, but we have, great cross-Atlantic ocean work in order to ensure that engines that have been originally developed in Europe are suitable. I'm talking about the two smallest are suitable for the United States. Very soon, and probably you have seen already announced that there will be additional diesels coming to the U.S. market. The Equinox I mentioned with the 1.6, and the van. The van has been using in the past the Duramax engine, and you will see it pretty soon with the 2.8. A little bit of downsizing, if you want, from 6.6 to 2.8 for professional users, for normally van drivers.
Yeah, we've seen the Sprinter market, so that makes sense.
Makes a ton of sense. LGHs are a hassle anyways, to be honest with you.
It's a lot of motor for a van.
It is, yeah. They run into that.
I would say that with the lineup that we are offering today, Chevrolet is probably offering today a really broad portfolio of diesel vehicles. We include the range, the SUV, compact car, mid-size, full-size, heavy-duty truck, and we're very proud of this, and we believe to be on the market with the right products, and we continue to develop and to have the outlook for the diesel technology that at the end of the day, despite going through quite difficult period, if you want, it remained really the most efficient way to bring thermal energy into mechanical work. And that's what we are doing and will be continuing to do.
Yeah, I'm glad to hear that. Glad to hear you're passionate about it. It's it's exciting to hear GM continuing to move forward on these platforms.
Yes, of course, we are moving forward in all the other directions as well, but this is for truckers and for commercial users and for passenger cars. This is a really attractive alternative. And we have the expertise in the diesel engines. We built millions. Only the trucks were here in the United States for a few years. We're coming with more products, and we have all the knowledge that is needed in U.S. and in other countries that contribute, the other countries where GM has development centers which are contributing to this, to the quality and the success of these products.
Preaching to the choir. I love it, man. I love it. We are excited over here. Again, thank you so much for your time. This has been so insightful for our listeners.
It's very apparent why they pay you the big bucks over there at GM. So.
Thank you very much. It was a pleasure for me, guys.
Well, listeners, this has been Paul Wilson.
I'm Danny Voss.
And Nick Pregnitz.
Thanks for listening.
The Diesel Performance Podcast is brought to you by Calibrated Power Solutions, home of DuramaxTuner.com. Calibrated Power develops emissions-equipped calibrations for a wide variety of diesel powertrains, including Duramax, Cummins, PowerStroke, John Deere, Case, New Holland, and many more. For more information and the best customer service in the industry, check out calibratedpower.com or call 815-568-7920. That's 815-568-7920. If you'd like to contact the podcast, send us a message through Facebook or email Paul at DuramaxTuner.com or Chris at CEHMKE@DuramaxTuner.com. Hey, thanks for listening. Your feedback is appreciated. Please rate and review us on iTunes, subscribe on YouTube, like us on Facebook, and by all means, let us know if you have any ideas for a podcast. We'd love to hear from you.
And I mean, I've had guys already like, hey, I want to tune. Well, I'm not going to use your truck as a test dummy, even if you volunteer it. I don't want it.
No, it
Let
doesn't.
us do it in-house. We want it controlled. We want to know the quirks, gains, downfalls. We want to experience it firsthand. We want to have the seal of approval when we go to market with something. Are we ever going to be the first? No, we're definitely not.
Yeah.
Will I feel that what we bring to the table is better than anything else on the market? Well, yeah, I truly do.
Right.
But that takes time.